the problem is sort of cultural with Hibernate, right? So developers tend to use these kind of ORM libraries because they're really sort of uncomfortable with just raw SQL and raw database access. But he says, yeah, actually, you should be very proficient and very comfortable with using what's underneath Hibernate, and of course, on the Java platform, that's JDBC and SQL through JDBC to the database. It doesn't replace that; it just builds on top of it. It's extra abstraction. And well, things can get messy then, right? That's basically what it says. That's the cost of the extra abstraction. So this last sentence I can really empathize with, and I really agree with it. And he says, save yourself some effort and pay attention to the database at all stages of development. About this cost of abstraction, I mean, this is really where you get into sort of a philosophical debate about, okay, should the abstraction be perfect? Should I really have to know anything beneath it? Because when I'm writing a web application, I don't really think about the TCP IP packet size that's underneath the whole stack. And when I write other high-level applications, often the concerns of the lower levels are completely hidden from me. But not so with Hibernate. So we can debate about whether that's good or bad, but in the end, it's just a fact of life. And on the other hand, Hibernate gives us a lot as well, right? In terms of productivity, in terms of automatic mapping between relational result sets and objects, generating queries for us. So really, we gain a lot by using Hibernate as well. So maybe it's not that bad to take a little pain every now and then. It's quite popular currently to really hate object relational mapping in the blogosphere, and I don't know if you read it, but Martin Fowler also wrote about it on his wiki, and there he really sort of defends object relational mapping, and his main argument is, right, well, it's currently all we have, right, because it's the best we can do short of doing everything by hand, and I think that's the way you should look at Hibernate as well. It's the best we can do, but it's not perfect. Maybe it will be sometime, but currently it certainly isn't. And why is that? What I'm showing here is, and it's not necessary to look at the details of this picture, but it's a structural analysis of the Hibernate code base on a package level. And red is bad, because red means there's a cyclic dependency between packages. Which often means that the implementation is really tangled together. And actually there's a tangle of 37 for someone who's familiar with the metric of package tangles inside the Hibernate code base. So you should really know that you're bringing a hugely complex system into your application at the moment that you're using an object relational mapper. And I know there are many tutorials who paint a very rosy picture and who show you how to get started very easily with ORMs. But I'm sure we've all followed these tutorials, and yes, they do work, but when you get to an actual application and when you get to an actual real system with lots of data, then things will break down rather quickly. So, how did it grow this way? Well, first of all, of course, it's just a 10-year-old code base, more than 10 years old, even I believe. So things just tend to evolve into chaos if you're not really paying attention. But another interesting thing, and it's also said by Gavin King in an interview, is that he says, well, most of the performance problems that are encountered by people using Hibernate, yeah, we couldn't really solve those by tuning the existing code in Hibernate. So what we do instead is we expose additional functionality, which of course exposes more of the native capabilities of the database to the developers using Hibernate. And it gives us more tools in our toolbox to tune the performance. But again, it makes Hibernate itself much more complex to work with. So this also goes to show that the abstraction is kind of leaky. I don't know if you know the term leaky expression, but it really fits Hibernate in this case. And I'll almost stop quoting now, I promise, but just this last one by the first Turing Award winner, who's sadly not among us anymore, but he had a very apt quote. He says, well, you can't really communicate real complexity. The best you can do is bring awareness about it. So that's what I'm trying to do today. I'm trying to bring some awareness about what you should think of when using Hibernate. And not just for your tutorial-based projects, but for real-world big data projects. So with that said, a little outline for how we proceed. I'm going to be talking a little bit about optimization in general, and then we'll dive right into specific Hibernate constructs that I think are really important to know. It starts, of course, with lazy loading. Now, I'll pick some examples from projects that I actually worked on and in which I encountered some performance issues and had to solve those using Hibernate. So optimization in general. Optimization is hard. I think we all agree on that, because you have this nice working application, it really does what you want, and then some customer calls and says, well, it's slow, it doesn't work, and you think, well, I tested it on my little toy database, and it's all perfectly fine. And then you have to go tune your application, but really, you do not want to change your application per se, because all the semantics, all the functionality are already there. So, in the most bad case, you only make it worse, right? And if you dive into a framework like Hibernate, there's always the question of where's the issue? Is it in the implementation of Hibernate, or is it in my way of using Hibernate, or am I just plain using Hibernate in a use case that's really not suited to Hibernate? Sometimes you have to think outside of the Hibernate box and try other tools. Maybe drop down even to JDBC directly and do things. Those are all things that you have to be aware when you're optimizing. And the first question, of course, is when are you going to start tuning your Hibernate code, right? Because you may walk out of the session and think, oh, I've read some nice tricks, I'm going to apply them right away. But I wouldn't recommend that, because once you're going to use Hibernate-specific features and Hibernate-specific tuning options, it will make your code base less portable, more complex, maybe a bit less maintainable. So only do this when there's a need to optimize, and when you have actual customers calling you and saying, this is not acceptable, please fix it. And of course, you have to preserve your correctness at all times when you're tuning performance. It's a bit like refactoring, right? If you're refactoring, you're changing the shape of your code to make it more concise or to make it more elegant. Or, anyway, you're doing stuff to your code, but you do not want to change the functionality of your code. And unit tests can help when you do refactoring, but they're not really helpful when you're doing Hibernate performance tuning, because Hibernate lives on this edge between your database and your application code. And you really want to be talking to an actual database to see that everything is working. So always make sure that you also have a suite of automated integration tests available. And as Donald said, premature optimization is the root of all evil. So really have a good reason to optimize and have a goal also in mind. Don't just go around and try and change things in your code base just because you think it's nice. So how will you go about tuning your Hibernate and your database code when there is a need, when you have an actual customer who complains? Well, first of all, a big mistake would be to get your development machine and to try and replicate everything there and try and tune it there. Because in the end, your application will be running on in a much different environment. Maybe it will be virtualized, maybe it will be running on a multi-core server with lots of memory. All those, you have to take into account at the moment that you're trying to tune Hibernate. Another thing that I see a lot is that people tend to focus on execution times. How long does this query take? How long does this data access object method take? And that's, of course, a valid metric, and we would like to reduce the time that the query takes. But there's also another component to optimization, and that's about memory usage. This is called space in this this slide. Because in the end, if you have too much information flowing into your JVM, your heap will grow, which means that there will be more and longer garbage collections. So this is also something that can influence the performance of your application. So always measure time and space, not one or the other independently. And as Java developers, it's very easy, of course, to grab the tools that we all know. You grab a profiler to profile the JVM, see how long methods take, etc., etc. But actually, when you're tuning your database access code, you will have to look at the database itself as well. And it differs from database to database, which tools that are available for SQL servers. For example, something like SQL Server Management Studio, and I'm sure other databases have other tools as well. And you must get into this database and check out what's happening with the queries that Hibernate fires at the database. Is it using excessive I/O? Is it accessing the disk far too much? Are the caches not tuned correctly? Are the statistics of the tables really up to date? Are the indexes using it in a good way? All these things you must do in order to tune your application. It's not just looking at Hibernate code and trying to squeeze out the performance there. And to do this, of course, the measurements have to be automated, because you don't want to be performing all these test runs manually and making an Excel sheet and recording everything. And, just make it repeatable and automated. It will be a bit more work in the first stage, but in the end it will really pay back. And one more thing, always make sure that you establish a baseline before you change anything. So really measure the system as it is without any changes, so you know whether something that you do really improves. Because sometimes I've had really good ideas and I implemented them, and it turned out that they're not that good at all. So you will have to detect that as well. So on a practical level, how will you go about tuning? Well, you can of course use a profiler to look at your data access object methods or your Hibernate code and see what's happening there, check the heap size using Visual VM, etc. You can also instruct Hibernate to generate some statistics about its inner workings through JMX, so you can monitor that as well in a JMX client. Those are really rough and aggregated statistics, but still they can be useful in lots of situations. And as I said, really look into your actual database and try and find tools that are available there to check out the performance inside the database. So it's not just sending queries and hoping the best. You can really get into inside the database and look what's happening there with query plans, optimizations, etc. So one last practical tip when you're analyzing the behavior of your Hibernate code. One of the most important things that you can do is look at the queries that get generated by Hibernate. There are several ways to instruct Hibernate to do that. You can either use some properties that you provide by Hibernate at the initialization time in the configuration file. The show SQL and the format SQL is necessary to give it a pretty format. So it's readable. And because oftentimes the queries that you will see pass by will make you scratch your head. How on earth did Hibernate come up with such a bad query? And then the fun begins, of course, and you trace back where this query originated, which actual call triggered this query, and you try to force it into some other kind of query. Another way to get this information is using a plain log4j configuration. You can do some sort of proxying or intercepting a JDBC driver like P6Py or log4jdbc. And these will sit in between your actual JDBC driver and your application, and it will monitor everything that's flowing through there. So be prepared to see a lot of logging if you enable the previous log statements that I showed. But still, you want to do this when you really want to know what's going on inside Hibernate. So first up, lazy loading. I guess most of us know what lazy loading is, right? So I'll be quick about it. It's a helpful tool to prevent loading the whole database in one go. So in this case, I have a little example. There's a request entity which has a one-on-one mapping to a user. And this user again has many authorizations, a list of authorizations, maybe thousands, 10,000 authorizations, I don't know. And there's a link to a company entity, and a company again is a global company. So when you retrieve this request, you're not actually always interested in all the information that's below. So fortunately, JPA has made some same defaults on the relations that you can have in your entities. So the one-to-one, the one-to-many, the many-to-many are all lazily loaded, which means that the actual data will only be retrieved when you access this lazy field of this lazy relation. The many-to-one, and it's a nice one to know, is actually eager by default. So if you do not change that, then it will always get these relations directly when you get the parent entity as well. And Hibernate also has a nice one called extra lazy, and we'll get back to that when we're talking about the very large collections. So most of the time, this is what developers encounter when they first think about lazy initializations, lazy loading. And I mean, who's seen this exception? Yes, I thought so. So really, what's happening here is that your entity has this lazy field, and you're trying to access it, and your session or your entity manager has already been closed underneath, and you can't get through the database anymore. So there are all kinds of workarounds to prevent these lazy initialization exceptions. You have, maybe you've heard of the open session review pattern, where you can extend how long your session is kept open until your view of your web application is rendered as well. So if you have this expression language that navigates through your entities, then the session will still be open, the queries can still be performed in the database. But in my opinion, it's just a flush. You don't want to do that. You want to handle it the right way. And lazy loading is also closely related to another performance issue that can creep up in your application. Because if you look at it, it may be very nice, right? All this lazy loading. Something is only loaded on demand, and so it will help you get nice performance. But there's also a flip side of lazy loading. And the flip side is that, let's say, for example, thinking back to this user object that I had in my slide, it's also defined here as an entity. Let's say that I want to select a list of 100 users, and all these 100 users have a list that is lazily initialized of authorizations. And let's say that I want to loop through these users and look at their authorizations and do some auditing or whatever. What happens then with lazy loading? Well, you retrieve the user, that's one query, and then while you're going through this loop, you will get 100 additional queries to the database to get these authorizations for each of these users. So, of course, that's really bad, because if you already know in advance that you're interested in these users and in all their authorizations, you might as well try and get them in one go, right? So there are several solutions to this N+1 Selects problem. And the one I find most interesting is the fetch join. So this is the original situation. We have this Hibernate query, select U from user, so retrieve all the users. And this results in one SQL query to get the users. And of course we're joining the company because that's an eager relation, so it will be automatically be retrieved. But the authorizations are not retrieved. And while we're looping through this result set, we access the authorizations, and there will be 100 additional queries to select from the authorization table where the user ID is equal to the user that we're currently looking at. So how can we solve this? Well, in this case, you can perform a join on the collection field. So in this case, the u.authorizations. And not just a normal join, but a so-called fetch join. In this case, it means that when you're retrieving all these 100 users, Hibernate will directly in this SQL query that you see also join in the authorization, and it will automatically link, of course, with the correct join on clause that the authorizations are linked to the actual user. So what you get is that in this case you will only get one query, which of course returns lots of data, but then you can look through it and do your stuff in your application. There's also an add fetch annotation, which is specific to Hibernate, in which you can specify how data is fetched. You can choose between a subselect, a select, or join. But if you put this on your actual field in your entity, you're already forcing it to always be eagerly loaded using this fetch mode. That may be what you want, but it may also be that you just want sometimes to have the users with all authorizations, and sometimes without them. In this case, you can use the fetch profiles. There's also a Hibernate specific annotation. And in the fetch profile, you can define, okay, for this authorization list, I want it to be fetched eagerly using a fetch join at the moment that this fetch profile is enabled. And you can enable fetch profiles on a Hibernate session using enable profile call on there. What I also see a lot when people encounter lazy initialization exceptions is that in their code, they just say, oh, okay, well, I just make sure that at the first point necessary, I'll just access this collection, for example, by calling it size, and then it will be fetched by Hibernate as well. It's initialized, and by lazy initialization exception is gone, and everybody's happy, right? Well, first of all, this size call, this other call on this collection is really meaningless, so please don't do this. And second of all, you're still having the N+1 Selects problem if you take this approach. So fetch joins are the way to go in the case of lazy loading, where you know beforehand that you really need the information of the lazy fields. So what should you be tuning? Well, the defaults defined by JPA and used by Hibernate I think are mostly good. It does have some impact, this lazy loading, especially when you talk about lazy entity fields, because Hibernate will insert some sort of a proxy between the actual object and the actual entity and the entity that you will get back from the field. So you have to be aware of that, and there's also some limitations on the class hierarchies that you can have when you use lazy loading. But still, it's pretty good as is default. And lazy can always be forced to eager, using the fetch joins that I described, or the fetch profiles, or other tools. But the other way around is much harder. So once you've declared a field to be eager, it's really hard to make it somehow lazy again. So my advice would always be go with the defaults for laziness and use these fetch joins in your actual methods to tune for your specific use case, whether the fields should be retrieved directly. One other thing that always comes up when you're using Hibernate is, oh, we should have search in our application, right? No, it doesn't have to be really fancy, just a few fields, and then we're happy, and you don't need any fancy full text search, indexing, etc., etc. Just do it using the current database. So what you get then often is a sort of flow like this. You have the search form, you have a result list, and then people can click through to a detail screen which contains all the relevant details of the actual entity that you selected from your result list. So again, I'm talking about a user with authorizations here, but the screenshots are actually from LinkedIn. I'm not implying that this is the data model of LinkedIn, because it's not. But still, the principle is everywhere in applications, right? So one obvious solution will be to do a select query from the user table and build your where clause dynamically. And please use the criteria queries, not string concatenation, etc. to build these dynamic queries. But for the purposes of this talk, I just used an HQL query. And you just get all the users, and you print a nice result list on the screen, and then you let the user pick a result, and then you show this entity in the next screen. But again, you may have far too much information in this flowing into your JVM just for the purpose of this search. First of all, we're really just interested in a few fields that are shown on the screen in the result list, right? So that may be the name of the user and an ID to create a link to the next screen. And all of the other information is really not relevant. And also, why should they be attached entities to the current persistent context, to the current session? I mean, you're not going to do anything with 99 of the 100 entities that you retrieve. Just the one that your user clicks on will be used later. So, one very nice thing that you can do, and that not many people know about, is that you can instantiate your own objects in a JPA or a Hibernate query. And in this case, I do a select and I say new example, the user summary, and the class name needs to be fully qualified for Hibernate to find it. And I just select some fields that are relevant for my result list. So I select the ID, the name, and the status of the user. And the status and the name are shown, and the ID is used to create a link to the next page. And in this case, you will have a much more efficient search result list page. And of course, you have to create this POJO yourself, with the correct constructor, in this case, using 3 fields. And I've even used another pattern where I just drop down to a straight up JDBC query, which joins all kinds of other tables that were relevant for a particular search. And it just gave back some fields and some IDs. And then these IDs, you can easily use these IDs again to retrieve the actual entity on the result page, on the result detail page. So there are many options here. Just try to stay away from selecting a lot of entities just for the purpose of displaying a single list of search results. An alternative would be to use this form, where you just select a few fields of an entity, and then you will get back a list of object arrays. This saves you from writing this POJO, but on the other hand, you will now have to go through this object array yourself and cast all the results of the ID, the name, and the status to the actual type. So I'm not really sure that you're winning much there. So as far as I'm concerned, you should use the POJO approach. Still, we're not satisfied, of course, because we were retrieving all the users that were relevant for this search query, but oftentimes you also have pagination, right, in your screens. So fortunately, there's an API for that as well in both JPA and Hibernate. You can set first result and do set max result to only get the 15 first users. So pagination, please do it in your Hibernate or your database code, not in your application code, because it's just a waste. One other thing is that you often have to do an extra count query, right, for displaying the total number of pages and displaying the total number of results. So that may still be necessary in this case. There's one nice interaction between the fetch joins that we talked about earlier and the pagination that I've shown here. Because if you call set max result or set first result on a query that involves fetch joins, this is coming from the JPA spec, by the way, the result, the effect is undefined. So that's pretty nice, right? It can do anything it likes. And if you think a little bit about it, then it actually makes sense, because in this case, if you have a fetch join from this user to this authorizations, you will have as many rows for the user as there are authorizations for this user. So you really can't do the pagination in the database anymore. You must do it on the client side. So that's something to be aware of as well when doing these kinds of queries. Reporting, analytics, well, same goes here. You really don't want to do this using entities, in my opinion. I mean, simple things like sums and averages of various fields, you can do that using Hibernate queries, using JPA queries. But there's a reason that those databases that we use are so powerful, right? They have these really powerful analytics queries built in, like petitioning, sliding windows, grouping, etc., etc. So my advice here will be just to create a native query that uses the power of your database. Because in the end, you're paying a lot of money to use Oracle, you're paying a lot of money to use SQL Server. You might as well get the best out of it. And far too often I see people just retrieving lots and lots of data into the JVM and then doing this reporting, this analytics in memory. And that may be nice, but it sucks for performance. Another trick would be to create a view in your database that uses these advanced queries and just map an entity to this resulting view. It's a trick I use a lot as well. And the advantage of that is, of course, that you still have a simple entity and a portable application that doesn't really tie directly to the database functionality because that's hidden behind the view. So, large collections and Hibernate are not really good friends. I'm not sure if you found it out already, but if you're persisting collections with thousands of items, then things tend to get slow as well. And I had an application where we had this model. We had a front-end application where you could request a certain company group, which consisted of companies that you selected. And in the end, it will result in a company group in a backend application as well, which has a slightly different model because we had a linking entity between the company group and the company to add some metadata. But anyway, I'll speak a bit about this example. The important thing is that these lists of companies can be fairly large, in the order of thousands. So in this case, it will be a many-to-many set of companies. And in the backend, there will be two entities because we have this linking entity to the company, where there's a one-to-many association from company group to company in group, and the company in group links to the actual company using a many-to-one, who's made lazy, by the way, because by default it's eager. So we had this problem in the front end that opening several large groups was kind of sluggish, right? And at the time I didn't really realize it, but this had everything to do with the N+1 Selects problem. Because we had many of these company groups that we were showing, and we were doing a count on the number of companies that was in the list. And we're iterating in a loop, and it would emit all these queries for each company group. And then I went looking, and I found the batch size annotation, which is Hibernate specific, but very useful. And in this case, I added this batch size annotation to this collection of companies. And what it actually means is that if you have all these company groups, let's say you have 100 company groups in your actual persistence context, and you access the first lazy list of companies in one such a company group, then Hibernate will try and get this collection of companies, of course, because it's lazy and it still has to retrieve them. But it will also look into your persistent context from, hey, are there any other company groups with uninitialized lists? If yes, then go and fetch all of these company groups now in the single batch as well. And do this for up to a maximum of 100 collections that are not initialized yet. So obviously this made the performance better. And you can also do this on the entity level. So if you have a lazy field that references an entity, you can also put a batch size on this lazy field, and it works the same way. Whenever it encounters a single field, it will really try and fetch as many as it can in one go for all the uninitialized fields. So that's nice, but of course in hindsight I should just have used fetch joins in this use case, right? Because I already knew that I was interested in all the companies that were in these lists. So there's a sort of correspondence between these features of batch size and fetch joins. I already talked a bit about extra lazy, which is kind of nice, but also Hibernate specific. And in this case, if I would have added the add lazy collection and the add index column on a list of companies, then Hibernate would emit very efficient queries for the following calls. If I would call the size on this list, it would just do a count query without really reading the actual companies. If I would do a contains query, if a contains call on this collection, it would do a select one and do the actual comparison in the database with the appropriate where clause. And the same for getting a certain company at a certain index in this list. So that's what the index column annotation is for. So that's a nice thing to keep in mind. But of course, once you really need to loop through these companies, it will retrieve them all again as well, like it would with a normal lazy collection. So this was reading collections, but saving was a bit slow as well. In the case of several thousand companies in the company group, it took over 15 seconds. The problem was that it's a row by row insert. So really the overhead was in doing all these separate calls to the database. Fortunately, there's also a solution there. This is called the JDBC batch size, which is a very low-level property because it's about how the JDBC is batching, and it enables JDBC batch statements. In order for this to work well, you should also use the Hibernate order inserts and order updates property, because in this case, batching only works when you have a sequence of queries that are of the same format, right? So either a sequence of inserts to the same table or a sequence of updates to the same table. But once you interleave different inserts into different tables, then batching doesn't work at the JDBC level anymore. And these two properties will help Hibernate to order them before it shows them into the JDBC batch. So to this backend model then, there we also have this large collection only with an intermediate entity, which made things a bit more interesting because saving this entity also meant inserting into this company in group table, right? This intermediary table. And it had a generated ID. And what happens at the moment that you have an entity with a generated ID is that after each insert, Hibernate will have to get this generated identity from the database by, for example, selecting the add identity in the database that I used. And as you can see, now you do not have a perfect sequence of same formatted queries anymore. It's interleaved, right? So JDBC batching doesn't help us anymore. It won't work because there's not a single stream of similar inserts anymore. Well, we improved this by generating the ID in the application, because we could easily do that using the combination of the company group and the company ID. But it's not always feasible. So if you cannot do that, then yeah, you have a problem in this case. Another solution that we used, because this was a backend service, it really made no sense to have all these companies and company group entities and company entities attached in your persistence context. Because we were not going to retrieve them later anyway. We just wanted to write it to the database, and it was a SOAP service call, a web service call. So we just wanted to return, okay, it's done, and we're done. So in this case, Hibernate has a nice feature called a stateless session, which bypasses almost every automatic feature that Hibernate has, but gives you a very efficient way to insert things. So in this case, the stateless session, you can get it with this piece of code from the Hibernate session. And the thing to note here is that you are responsible yourself for cascading any actions to the underlying collections, etc. Hibernate will not do that anymore for you. So that helps a lot in keeping the space usage of Hibernate down, but it has some downsides, like I showed here. There's lots of things that Hibernate won't do for you when you use a stateless session. So, now it was very fast. Everybody happy, right? Well, not really, because here I think the complexity of Hibernate really shows through. We had some, fortunately, we had some automated integration tests, and these detected that data just got lost. We inserted, for example, 1,200 companies in this company group, and only 1,000 were persisted to the database. That's really bad, of course. So what happened there? It turned out to be a really nasty interaction between the JDBC batch size and the stateless session users. Because what would happen is that this stateless session would only flush completely filled JDBC batches. So if you had a batch size of 100 and you were inserting 150 entities, then it would only insert the first 100 because that was a complete batch, and the last 50 were just left up in the air somewhere, never to be found again. So I logged this on the Jira of Hibernate, and it was closed as a log fix because, well, Hibernate is not meant to do batch processing. What? I was just trying to store a collection of about 2,000 items. I mean, that's not really out there, is it? And the most ironic thing is that the link they provided to the reference manual was to the chapter batch. Well, okay. Anyway, there's a workaround which I used, and I've shown it here in the Jira comment as well. But it's really ugly, of course. You're forcing Hibernate to execute the batch just one more time, just before you commit, to make sure that this last half-filled batch is also executed. So with this, I think I will go to the questions because my time is almost up. As said, the slides will be posted. There's some little odds and ends that I won't be able to speak about today, but you can look at the slides or you can talk to me later. And I hope you've learned a little bit, and I'd like to take questions now.
Why is this problem with additional selector drivers ID? If you, for example, use sequence, it would be automatically generated in insert.
So if you use, for example, an Oracle sequence.
Yes.
Yes.
And you could emulate the number of inserted entities based on the value of the sequence after the batch.
Okay. So the problem here is just that the ID is generated inside the database, right?
Yes.
And Hibernate guarantees that after it inserts an entity, the actual ID of this entity will be in its ID field. So it has to get the ID from the database into this ID field. And it does this in various ways. If you use this as automatic generated identity, it uses select. For sequences, I'm not quite sure how this works. You seem to be proposing that you just do the counting in your application code as well of the sequence, and that might be feasible, but I think you will easily run into concurrency problems there because this counting in your application code will not be part of the transaction, right?
Yes, but if I could guarantee that this insert will be the only statement that executes, I could actually rely on this.
If you could guarantee that might be feasible, yes. But most applications that I work on, we have concurrent access. So, yeah.
Okay.
Thank you. No questions?
Sorry, one obvious question. If you will start developing the new project, will you use Hibernate?
Actually, that depends. I've recently started 3 projects, 2 of them using Hibernate, and one of them just using plain JDBC, using Spring JDBC template, just to take away all the boilerplate. But in this case, in the case of that project, Hibernate really had no advantages. I mean, it's nice to have this automatic mapping from your result set, but other than that, it would only get in the way. And sometimes it's just better to write queries directly in SQL. Yeah. So one of my next was also, there are other solutions, right? Using JPC directly, or using something like MyBatis, eBatis, which is a bit closer to SQL than Hibernate. Or even looking at frameworks like Square, which is for Scala specific, but it's very nice as well for data access. Okay? Any other questions? Over there.
The last question.
Hi, is there a difference from the performance point of view to use criteria or HQL for search queries?
Okay, the question is there difference in performance between criteria and the string-based queries? As far as I know, no. Ultimately, the same SQL will come out. Problem is that the criteria API is not quite as complete as the actual string-based API, so you can do less with it. As Arun in his previous talk already pointed out, you can only do read queries, right? No updates, etc. And you can do those, but for performance, there's no difference, as far as I know. Sorry about that. Yeah, we're finished. Okay, thank you.